Aircraft systems. Engine. The BE-76 Duchess has two 4-cylinder Lycoming O360 A1G6D opposed 360 cubic inch carbureted engines. Each engine has rated 180 horsepower at 2,700 RPM. The right engine is designated as an LL360 due to the fact that it rotates to the left. The engines are direct drive crankshaft connected directly to the propeller. Horizontally opposed pistons oppose each other, piston driven and naturally aspirated. Propellers. The Duchess is equipped with Hartzell controllable pitch, constant speed, full feathering metal propellers. A feathering lock prevents feathering during engine shutdown if engine speed is less than 800 RPM. Controllable pitch is the ability to control engine RPM by varying the pitch of the propeller blades. When the blue propeller control handle is moved forward, oil pressure regulated by the propeller governor drives a piston which moves the blades to a low pitch, high RPM, unfeathered position. When the blue propeller control handle is moved aft, oil pressure is reduced by the propeller governor. This allows a nitrogen-charged cylinder, spring, and centrifugal counterweights to drive the blades to a high pitch, low RPM feathered position. Constant speed. After RPM setting is selected with the blue propeller control handles, the propeller governor will automatically vary oil pressure inside the propeller hub to change the propeller blade pitch in order to maintain a constant engine RPM. Because of this, changes in power setting, manifold pressure, and flight attitude will not cause a change in RPM. Full feathering. When the propeller blades are in alignment with the relative wind, they are feathered. Feathered propeller blades reduce the drag caused by the blade area exposed to the relative wind. Feathering the propeller blades on the Duchess is accomplished by moving the blue propeller control handle fully aft past the low RPM detent into the feather position. The propeller takes approximately 6 seconds to feather. When feathering the propeller, the mixture should be placed to cut off to stop engine combustion and power production. The Duchess is equipped with a feathering lock that prevents propeller feathering below 800 RPM. The purpose of this is to allow the propeller blades to remain in a low pitch upon engine shutdown. This will prevent excessive loads on the engine starter during the next engine start, regardless of the prop lever position. If oil pressure is lost, the propeller will feather when the RPM is above 800 RPM. Typically, RPM will be above 800 RPM in flight and on takeoff roll and landing roll due to airflow over the propeller. Propeller overspeed is usually caused by a malfunction in the propeller governor, which allows the propeller blades to rotate to a full low pitch. If propeller overspeed should occur, retard the throttle. The propeller control should be moved to full decreased RPM and then set if any control is available. Airspeed should be reduced and throttle used to maintain a maximum of 2,700 RPM. Propeller and governor ground checks. As a part of the run-up checklist, the propeller and propeller governor systems are dynamically tested. This consists of 2 steps: prop feather and prop exercise, and governor function. The prop feather check confirms that the propeller is able to move toward the feathered position, which is critical in an engine failure situation where the drag of an unfeathered propeller would be detrimental. When the propeller control lever is pulled back, the propeller governor decreases oil pressure supplied to the propeller hub. This allows the propeller's internal spring, counterweights, and nitrogen pressure to increase the propeller blade angle, which decreases engine RPM. Additionally, it allows the relatively cold and thick oil in the propeller's hub to be exchanged with the engine's warmer oil, ensuring the propeller responds in a normal manner. The prop exercise and governor function check also circulates warm oil into the propeller's hub and provides confirmation that the propeller governor is able to maintain engine RPM. As engine RPM is reduced by the governor's command increase in propeller blade angle, an associated slight increase in manifold pressure can be observed.
Landing gear. The Duchess is equipped with hydraulically actuated, fully retractable tricycle-type landing gear. Hydraulic pressure for gear operation is provided by an electrically powered reversible hydraulic pump. The gear is held in the up position solely by hydraulic pressure. Springs assist in gear extension and in locking the gear in the down position. After the gear is down and the A-frames reach over center position, springs and hydraulic pressure Maintain the force on each gear to keep it locked until hydraulic pressure is released by reversing the gear pump with the gear selector switch. The landing gear hydraulic reservoir is located behind the aft baggage compartment of the airplane behind the cover. The motor and reservoir are located together. Gear retraction on the ground is prevented by an airspeed switch located in the pitot system. On the ground, the switch is open, preventing electrical current from reaching the hydraulic pump. Once the aircraft reaches between approximately 59 to 63 knots calibrated airspeed, the switch closes and allows current to reach the hydraulic pump. In the event of hydraulic malfunction, the landing gear may be extended by releasing the gear hydraulic pressure with the emergency gear extension tool. After placing the gear selector in the down position, turning the emergency gear extension valve releases the hydraulic pressure, which is holding the gear in the up position and allows the gear to free fall down. The positive gear down indication is 3 green lights. Emergency gear extension is limited to a maximum of 100 miles per hour due to the air load on the nose gear. Brakes. The Duchess is equipped with hydraulically actuated disc brakes on each main gear strut. Flaps. The Duchess has an electric flap system. The flaps are extended with the electric motor located underneath the 2 passenger seats. Flap settings are 0 to 35 degrees. When extending or retracting the flaps, the selector switch must be moved in the desired direction and then be returned to the neutral position to stop extension and retraction at desired setting. Fuel system. The Duchess fuel system has 2 50-gallon aluminum tanks in each wing with a 103-gallon total fuel capacity. 1 1/2 gallons are unusable in each tank, bringing the total usable fuel capacity to 100 gallons. Fuel must be 100 low-lead avgas. Electrical system. The Duchess is equipped with a 14-volt or a 28-volt electrical system which utilizes push-pull type circuit breakers, a 12-volt or 24-volt 35-amp-hour battery, and 2 60-amp engine-driven alternators. Stall warning horn. The Duchess is equipped with 2 electric stall detectors, one located on each wing. The left detector provides stall warning at flaps 0 to 16 degrees, and the right detector at flaps set above 16 degrees. The purpose of the 2 tabs is to provide adequate stall warning in various configurations with a varied angle of attack. Garmin G5. Our Beechcraft Duchess is equipped with 2 Garmin G5 electronic flight instruments in place of the vacuum-powered attitude indicator and horizontal situation indicator. Aircraft with G5 avionics have had their vacuum system equipment removed, including related gauges and annunciator lights. G5 pages. Each G5 has 2 pages, the PFD page and the HSI page. During installation, the units are configured to display the PFD page on the top unit and the HSI page on the bottom unit. The PFD displays altitude, airspeed at altitude, turn rate, heading, and vertical speed information using similar layouts to the Garmin G1000 but in a smaller form factor. To maintain commonality with aircraft with all conventional gauges, standard procedure is to use the G5 PFD as the primary source of attitude information only, while using the conventional gauges for airspeed, altitude, turn rate, and vertical speed information. Note: slight mismatches of a few knots or tens of feet between the airspeed, altitude information on PFD and the conventional instruments are common and not cause for concern. When setting the altimeters, enter the same pressure setting on both. Do not modify one setting just to make the altimeters match. The HSI page functions like a standard HSI, showing the heading and either VOR, lock, or GPS course information, depending on which is selected on the NAV1 GNS 430. The selection knob normally adjusts the heading bug to select a course, then first press the knob to enter the menu and select course for OBS if using the GPS data, then use the knob to select the desired course. G5 failures. As with other Garmin glass panel instruments, failures of the G5 instrument functions are indicated by a red X over the affected area. Failures in flight can be addressed by using other cockpit instruments, or in case of attitude failure by switching the bottom unit to show the PFD page. To switch pages, press the selection knob to activate the unit's menu, then rotate to select the PFD page. A exclamation point icon in the lower left indicates a new system message. Press the selection knob and rotate to select and read the message. The G5 Pilot's Guide lists possible messages and their meanings, most of which alert the pilot to system faults. G5 electrical power. For redundancy, the upper G5 unit is powered from the main bus and will turn on with the battery master switch, while the lower one is powered from the avionics bus and will turn on with the avionics master. The G5 instruments also have internal backup batteries that can power the device for up to 4 hours if aircraft electrical power is lost. If this occurs, a system message will appear and the battery status indicator on the upper left of the screen will display the remaining battery charge time. Exit IMC and land as soon as practicable. A professional pilot is smooth and coordinated.